Hey guys, welcome to day 11 of solving Leetcode daily challenges. So today's problem is cheapest flight within k stops. Let's see what the problem is. There are n cities connected by some number of flights. You are given with an array flights where flights of I is from, to and price indicates that the flight from city from I to the city to I with the cost price I. So you are also given with three integers source, destination and k. We need to return the cheapest price from source to the destination with at most k stops. If there are no such route, we need to return -1. Let's see what is the problem. So here we are given with a simple example. Here the source is 0, destination is 3 and k is 1. That means we need to reach from source 0 to destination 3 within one stop. So let's see this example. Here we are given with a graph that is from source 0 to source 3 we have only two paths, that is this path and this path. So we need to find the minimum cost in this case within two stops. So when we consider the first path that is from 0 to 1 to 2 and then we reach 3, we see that we have two stops here. So we consider the other path that is from 0 to 1 to 3. Here we have only one stop which is valid and the total distance is 100 plus 600. The answer will be 700 as cost, but here we get the cost of 100 plus 200. That is, we reach destination 3 with only 500 as cost, but we see that it takes two stops. So we can't take this path although we reach it with a lesser price. So let's think of another example to understand the problem. So let's consider this graph as an example with the cost from 0 to 1 as 2. Let's take it 1, 2, 2, 1, 1 and 1. Okay, so let's take 0 as source and 2 as our destination, and let's consider k equals to 3. That means we need to reach 0 to 2 within 3 stops. For solving this, let's take a simple priority queue, or we can take only a simple queue. So in this we are going to store the number of stops, the node and the distance. Let's take a distance array to store the distance from source to other nodes. Let's mark it as 0, 1, 2, 3, 4 and 5. And initially the distance from source to source is 0, and let's take infinite in every case or to every node initially. Okay, so initially our queue will have 0, 0 and 0. That is, the number of stops is 0 and source is 0 and distance is 0. Let's take 0, that is we have two paths here from 0. So from 0 we can move to 3 and we can move to 1. Now we'll consider first that number of stops is 1 and we are reaching to node 1 with cost of 2. So let's say 1, 1 and 2. And now we are taking 3. So from 0 to 3 the cost is equals to 1 and it is 3 as node, and we take only one stop. Now update the distance of these as from 0 to 1 we take 2 distance and from 0 to 3 we take 1 distance. So let's say now we are gonna remove this from the queue and consider this. So now we'll take 1 as the node, current node. We see that we can reach to 4 and we can reach to 5. So let's say for reaching from 1 to 4, we take the distance of 2 and total distance from 0 to 4 will be equals to 4. So we'll just update it as 4 and append it into the queue as number of stops will be incremented by 1 and we reach node 4 with a distance of 4. Let's say we have moved from 1 to 5. So we have the distance of 1. So total distance to reach from 0 to 5 will be equals to 3. So update the distance to 3 and the stops will be 2, 5 and it takes 3 as the distance. Now we see that there are no more travelings from node 1. So let's pop the next one out as from third node. You can see that from node 3 we can go to 1. But we see that 1 is reached already with lesser number of stops. So we don't consider this path. Let's move to the next one. So pop this out. We see that from 4 we can reach to 2 and no more paths. So just update the distance as here 4 and it takes extra 1 distance. So it will be 5. Update the distance of 2 by 5. Next we'll just pop it out this and can see that from 5 we can go to 2 with the extra cost of 1. So now we see that it takes 4 as the distance but we have 5 which is minimum in these two. We see that 4 is minimum, so update it to 4 and just append both as let's say 3 and 2. By taking 4 as the node, intermediate node, we take 5 first and then 3 stops to node 2 and it is taking 4 distance. We see that it is the destination, that is we have reached the destination and let's consider the number of stops here which is equals to the given k. So just stop the loop and return the minimum distance, that is 4, which will be our answer. What if number of stops is equals to 2? That means we can't reach the 2. So we just return -1 in this case. Let's move to the code part. First we'll create a graph, that is by taking a adjacency list as default of a list. We are creating a graph here and then let's say for I in flights u comma v comma cost equals to I, that is we append the adjacency of u equals to or dot append v comma c, that is in from address we append to and the cost of the given flight. So next we'll move to q, that is let's say deque, and now just append the source, that is 0 source and 0, that is number of stops is 0 initially and the source is the initial one and 0 is the distance. Now initialize the distance as float of infinite for every city, that is n number of times. Now the distance of source is equals to 0. Let's say while q is not empty, what are given here v and c. So let's say node comma the cost or okay, so stop node and the cost is equals to q.popleft of. That means we are taking the minimum in the queue or the topmost element. So now let's say for I in adjacency of the particular node, if or we can take a condition here, that is if the stop is greater than k, just continue, means we need to just pop out every element in the queue. And let's say node comma the weight is equals to I in the adjacency of node, and let's say if the cost plus the weight of the adjacent node is less than the distance of the node, then just update it, or let's say distance of node will become cost plus the weight, and q will be updated or appended by append the particular stop, that is stop plus 1, and the node and distance of node. Now let's say we have appended everyone and stops have been popped out. Let's say the distance of the destination is if the distance of destination is equals to float of infinite, that is if the distance is equals to infinite, just return -1, else will return the distance of destination. So let's run the code and see if it runs fine. Okay, so the code runs fine. Let's submit it. Yeah, the code is submitted successfully. So that is it for today, guys. If you have liked my video, please like and subscribe my channel. Thank you for watching.